Hello everyone. We are Group 22. We are here to present BrainNet project. This project is about using brain signals to do privacy management for smartphones. So first we'll do a demo of the Android application which performs the login and registration activities, and then we'll move on to the Fog server setup and the cloud server setup. So for the registration part, first we'll create a user over here, and then we select a signature file from the local storage and we hit create. So when we hit create, the Android app sends a request to the Fog server in this case, along with the user ID as well as the brain signal file. So as you can see, the Fog server stores this information into MongoDB and sends back the response saying that registration is success. So there are a bunch of information that we display on the UI screen over here. So in this case, we have used Fog server for the computation, and the execution time is 2267 milliseconds. And we have also displayed the round trip time and the network latency time. So in this case, our threshold algorithm has selected Fog server depending upon the round trip time and the execution time, and as well as the availability of the Fog server within the same network. And we'll perform the login activity for this user that we created right now. So we'll select the same signature file over here and we hit login. So when we hit login, this request is again sent back to the Fog server, which retrieves the information from the MongoDB and performs the comparison and returns whether the login was successful or not. As you can see, the login success message is displayed on the UI screen along with the other information that we displayed earlier. So we'll also do the login in unsuccessful case. So here we have selected a different signal file and send the login request again. So this time, as you can see, the login failed message appears on the UI screen as we have selected a different login brain signal file. So that's the demo of the Android app. Now we'll do a code walkthrough of the Android app that we demoed earlier. So as you can see, this is the utility function that actually performs the post request to the Fog server and the cloud server. So over here, we calculate the round trip time by identifying the start time and end time and displaying these details back in the UI over here. And this is our activity main.xml where we have the login screen and the registration screens, and we have a bunch of other helper functions that actually performs several other activities during registration and login. Before we move on to the cloud server setup, let's take a look at the architecture of our system so far. So we have our Android mobile app over here, which performs the login and registration activities. Internally, this app uses the threshold algorithm. So this threshold algorithm works based on certain parameters. So we have network latency, we have round trip time, we have Fog server availability in the same network as that of the Android app, we have the server execution time, and we have the power consumption. Based on all these factors, threshold algorithm determines whether to use a Fog server or a cloud server. So the part where the threshold algorithm uses the power consumption is still pending. That's a pending task. So now the Android app either connects to the Fog server or the cloud server. So the Fog server is present on the same local network, which uses a local MongoDB to perform the computation and send response, whereas the cloud server is currently hosted on Microsoft Azure. So we have a Spark REST server. It's a Java-based REST server to perform the REST activities, and it internally uses MongoDB. And this cloud server has a configuration of 3.5 gigs of RAM, and it's based on a Windows 10 professional operating system. And we have the extractor module over here. So the input to this extractor module is a signal data file that is received from the Android app. So this extractor module internally uses fast Fourier transformation to extract the features from the signal data, and this module internally uses MATLAB compile runtime environment to perform this extraction. And this extractor module returns an object array, which is a float value array, which has the features. And we have the comparator module over here. So the input to this comparator module are two object arrays belonging to two different brain signal data files. This comparator module internally uses naive Bayes classifier to perform the comparison, and this also internally uses MATLAB compile runtime to perform the comparison. So the output of this comparator module would be either a 1 or 0. So 1 corresponds to a successful comparison where there is a match between the two object arrays, and 0 corresponds to an unsuccessful comparison where there is no match between the two input arrays. So now let's move on to the cloud server setup. So as I mentioned, this is the application that is currently running on Microsoft Azure operating system, Windows 10 operating system. So as you can see, so when we receive the input file array and when we pass this input file array to the feature extractor returns an object array, which is an object of float values in it. And internally, to secure this information, we serialize this object into a Java object and we encode this object using base64 encoding. And this base64 encoding returns a base64 encoded string, which we internally store in the Mongo collection along with the user ID. So this is how our database looks like. So we have a collection called foo over here. It has a user ID and we have features. So this features is a base64 encoded string and this user ID is a string. So for each user, we store this information into this collection. So this is the Fox server setup that we have, which is an application running on a system, and the system is present within the same network as that of the Android application. So for example, we have the sample register activity over here. So if you look at this activity, so we are computing the server execution time based on the start time and end time over here. And over here, once we receive the file and the user, so we send the file to the extract feature module, which actually retrieves the features of the file, and then we serialize this object and then we store it into MongoDB along with the user ID and the features, and we calculate the computation time, which is the server execution time over here, and send back the response back to the Android application. So our accuracy algorithm determines the accuracy of the comparator module that we used for the system. So we have calculated the accuracy of our comparator module using real data provided by the Impact Lab. So this data has around 14 brain signal data files belonging to the same user recorded at different situations. Our comparator module couldn't match 5 out of 10 files belonging to the same user, which gives an accuracy of 50%. But when we compared signal data of one user with another user, the comparator always accurately determined that the files belong to different users, which gives us an accuracy of almost 100%. So to summarize, the comparator module had more false negatives than false positives. So now we'll move on to the project status and task distribution module. So as you see, we have listed all the 20 tasks regarding this project over here. And out of this 20 tasks, we have completed the phase 1, which is developing an UI to show image, video stimulus and obtain brain data. And phase 2 is the remote server setup, which is also completed as we have shown in the demo. And phase 3 is setting up the Fox server and developing an adaptive offloading algorithm. So the Fox server setup has been completed and the algorithm has also been completed. The phase 4 is regarding the perform analysis using Fox server versus cloud server for the database. So over here, we have completed a bunch of activities where we recorded execution times of both Fox server and cloud server and the accuracy of the detection module. Whereas the couple of pending tasks that we have so far is regarding the power consumption of the smartphone when using Fox server or cloud server, and comparing Fox server only versus remote server only, and versus adaptive offloading techniques with respect to execution time and power. So out of 20 tasks, we have 2 pending tasks, which gives us the completion status of 90%. And that would be the demo of Group 22 BrainNet project. Thank you.